All right, so we're going to talk about solving trig equations today. Some of these you might have to use some trig identities, you're going to have to factor, you're going to have to combine like terms, things like that. Okay, for the most part, this is just the same as your algebra techniques, right? You're going to move all of your constants to the other side, and you're going to treat your trig function kind of like your x or your y. It's the variable in the equation. So the first step is going to be to isolate that expression, and then you're going to set your trig function equal to some constant. Now, if we use the factoring method, remember, it's going to have to be equal to 0 because we're solving for the roots of that function. And then you're going to find out whatever angles you are looking for at that value. Two things to really keep in mind when we're doing this. You cannot divide by any sort of trig function because when you do that, you lose values. You're losing values for that function on the unit circle, so you cannot divide by a trig function. Second is square roots have two options. They are positive or they are negative, which means that it's going to give us 4 values rather than 2 if we had already had 2 values, because we're getting the whole unit circle rather than just 2 quadrants where it's positive or where it's negative. So let's look at our first example. We're going to isolate sine by itself, so I'm going to add 1 to both sides, and I'm going to get 2 sine of x equals 1, and then divide by 2, so sine of x equals 1/2. And now to myself, I'm saying x is going to be wherever sine is equal to 1/2. So sine is positive, right? Don't forget you're all students take calculus. Sine is positive in the first and the second quadrants, and it's 1/2 for the pi over 6 family. So it's going to be pi over 6 and 5 pi over 6. And that would be the solution. Okay, for the next one, again, we're isolating, so we get secant of x equals -2. Personally, I do not think in secant, cosecants, and cotangents. I think in their reciprocal functions. So I'm going to make this its reciprocal function of cosine, and I'm going to take the reciprocal of -2, which is -1/2. So now I'm asking myself, where is cosine equal to 1/2? Okay, that's the pi over 3 family. And then cosine is negative in the second and the third quadrants. So it's going to be 2 pi over 3 and 4 pi over 3. Okay, again, isolate our term, so we're going to get 3 tan squared of x equals 1, or tan squared of x equals 1/3. To get rid of something being squared, we take the square root, so we're going to get tan of x equals, this is where that positive or negative value comes in, the square root of 1 over the square root of 3, because when we take the square root of a fraction, we take the square root of the top and the bottom. So that's going to give me 1/3, 1 over the square root of 3, which I can't leave, so it becomes the square root of 3 over 3. And tangent is the square root of 3 over 3 for the pi over 6 family, because 3 plus 3 is 6. So we're going to have the whole family. So we're going to have pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6 as our solutions because it was positive and negative. Remember, when you take a square root, you get a positive and a negative value, so it's most likely going to be the entire family. All right, we want to get all of our variables on the same side and numbers on the other. So I'm going to move sine of x to the left, so I get 2 sine of x on my left side. I'm going to move the square root of 2 to the other side so it's positive. And then I'm going to divide by 2, so I get sine of x equals the square root of 2 over 2. And for this, Sine is the square root of 2 over 2 for the pi over 4 family, and sine is positive again in the first and the second quadrant. So it's going to be pi over 6 and 5 pi over 6. Notice that all the properties are of solving equations are pretty much applying here as we are solving our trig functions. Okay, so this is where you're tempted probably to divide out a cotangent. You will lose values if you divide out the cotangent. You cannot do that. You need to put everything on the same side. So we're going to have cotangent of x cosine squared of x minus cotangent of x equals 0. And I'm looking at this and I'm seeing, well, they both have cotangent. So I'm going to take out a GCF or factor out the cotangent of x. So I get cotangent of x. And when I divide cotangent of x by cosine squared of x divided by cotangent, I get cosine squared of x, and cotangent divided by cotangent is 1 equals 0. Now the most common mistake I see here is that you factor it out of the first part easily because you're left with a cosine, but then you forget that when you take a cotangent out of a cotangent, you get a 1. So please, please, please do not forget the 1. And now we have two factored pieces. We have our cotangent here in the front, and we have the cosine squared minus 1. Since we now have factors and they're set equal to 0, we will set both terms equal to 0. Okay, so when cotangent is 0, that means that x is 0 because x is on top. Okay, so when x is 0, or our cosine function is 0, that's going to be pi over 2 and 3 pi over 2. And then we're going to have cosine squared of x minus 1 equals 0. So cosine squared of x equals 1. And then we're going to take the square root of both sides. So we get cosine of x equals plus or minus 1. Okay, which when cosine is 1, it's going to be 0 and pi. We are not including 2 pi here because that is our domain. Our domain is going to be from 0 to 2 pi, not including 2 pi. So there we have our 4 solutions for that one. Okay, so here I'm seeing that I have a sine squared and a sine, which to my brain is telling me I'm going to have to factor. It's like having x squared and an x. Now, some of you have trouble thinking in terms of sine. It is okay to switch it back to your x's, but you have to remember to put your signs back in if that's the method you want to use. Okay, again, if you need help factoring, please come see me. I am more than willing to work with you in Bear Block on that. So we would factor this and we would get a 2 sine of x and it's going to be plus 1 minus 1. Okay, equals 0. And then we have our factors, and we're going to set each of those equal to 0 and solve. Okay, so here we're going to get sine of x equals negative 1/2, and here we're going to get sine of x equals 1. So sine is 1 at pi over 2. And sine is negative 1/2 in the third and the fourth quadrants. So that's 7 pi over 6 and 11 pi over 6. Okay, again, I'm seeing something squared and I'm seeing something not squared, but they're not the same trig function. So here I'm going to be thinking, well, how can I manipulate this to make it easier for me? I probably need to factor, which means I probably need a cosine squared. Can I get a cosine squared from sine squared? This is where trig identities come in. Remember, we have sine squared of x plus cosine squared of x equals 1. So if I manipulate this to get my sine squared by itself, I'm going to have sine squared of x equals 1 minus cosine squared of x. So I can replace sine squared of x with 1 minus cosine squared of x. So I'm going to have 2 times 1 minus cosine squared of x plus 3 cosine of x minus 3 equals 0. I'm going to distribute my 2 in, so 2 minus 2 cosine squared of x plus 3 cosine of x minus 3 equals 0. And I'm going to have 2 cosine squared of x plus 3 cosine of x. I have a positive 2 and a negative 3, so when I combine those two, I'm going to get a negative 1 equals 0. I do not like my first term to be negative personally, so I'm going to divide everything by negative 1 on both sides, and 0 divided by negative 1 is just 0, so that's why 0 doesn't change. We're going to get 2 cosine squared of x minus 3 cosine of x plus 1 equals 0. And then here, you're going to do your magic factoring, okay, and you're going to get a 2 cosine of x minus 1 and a cosine of x minus 1. Now, if you are in my B7, I miswrote the second piece there. So please make sure you look at that. Okay, so now we're going to split this up. We're going to get 2 cosine of x minus 1 equals 0, and cosine of x minus 1 equals 0. So cosine of x equals 1/2, and cosine of x equals 1. So cosine is 1/2 for the pi over 3 family, so it's going to be in the first quadrant and in the last quadrant. So quadrant number 4. And then cosine is 1 at 0. All right, the last one here, again, you still have to factor, and when you factor, you're going to get cosine of x plus 2 and cosine of x minus 1. Okay, so cosine of x plus 2 equals 0, cosine of x minus 1 equals 0. And here we're going to get cosine of x equals negative 2. Now, is 2 in the domain of cosine? That's the question you have to ask yourself. It's not, because cosine has a range between negative 1 and positive 1. And negative 2 is not in that range, so therefore there's no solution on this piece, or it does not exist. Okay, but this piece over here, we get cosine of x equals positive 1, and that does exist, right? So x is going to equal 0 there. If you have any questions on this, please feel free to sign up for Bear Block or see me in class.